SCARFF is a framework which enables credit card fraud detection. SCARFF stands for SCAlable Real-time Fraud Finder, and it consists of a pipeline including three Apache Big Data tools: Kafka, Spark, and Cassandra. This video is a guide on how to start a SCARFF instance on Docker, and more details can be found on the Docker Hub public repository, which is reachable on this link that I'm highlighting. So here you find the command needed to run our instance, which is docker run with some parameters and redirection of some ports and as privileged and Fabrizio Carcillo / SCARFF. So you copy it and you paste it on a bash terminal, and now you are in the container already. Now you need to initialize some tools as Kafka and Cassandra. To do so, you have a startup script in the SCARFF file folder, and so you copy and paste it again. You can run it, so it takes a few seconds. After that, you will start the streaming using a bash file which is datasend.sh with a parameter showing the speed rate of the streaming, and this is getting data from this small artificial dataset. And you also have a big artificial dataset, but it's quite big. So for the small one, the runtime is the running of the stream is 1 hour. So we copy and paste it to the Docker. It's running, and now we need to start our application. So Spark submit of a SCARFF jar file. So the job is starting. So depending on your processor, it can be faster or slower, depending also on the resources that you pass to Docker. The streaming performances can be monitored on this link. The IP depends on your Docker installation. After a while, you can kill the application whenever you want with Ctrl+C, but we will let it run till the end of the streaming of this small artificial dataset. It will last roughly 1 hour. So this is running here now, and if we check on this page, we have a first job running, first stage, and the streaming here. After 30 minutes, we have received 1000 records, and we have completed 9 batches, everyone with the duration of 3 minutes. And we can see that the processing time chart presents a dashed line, which is the stability line. So if we pass this line, which has just happened, we start to accumulate some delay. So also the scheduling delay is growing. It's moving from 0. This is something that we would not like to have in a real case scenario. This is happening because the streaming at this step is starting to train new predictive models. And so it is more expensive, it takes more time. After 1 hour and 20 minutes, there is no more data coming through, and we see that we have scheduled a lot of delay, but this should not happen in a real case scenario. Going back to the terminal, we check again that there are not data streamed. So we can quit our application with Ctrl C, and then we can check in the Cassandra table if there are some alerts raised. So we can copy the command, enter the SQLSH, and select star from the table where the alerts are contained. We see that there are many alerts. So some of them has a -1 for the probability of the model feedback. This means that we still don't have a model feedback, but we will have a delayed model. So we use it as a total outcome, while in cases where we have delayed and feedback models, we have an ensemble of the two. So what we should have, it's a lot of here we also have the real label. We should have a lot of true cases here. Obviously this is a almost random data set, so we don't have many frauds, but concentration of fraud is quite high also here.